Is Spring Webflux dead? It is 2026, and if you look at the code on the left hand side of your screen, it sure feels like a relic. It isn't just a code, it is a headache. For years, we traded our sanity for scalability. We wrote flat map inside of zip with, inside of subscribe on, just to squeeze a few more requests out of our CPU. We built complex pipelines just to fetch a user from a database. But look at the right side. That is Java 21. That is virtual threads. It's the same concurrency model, but with the code that a human being can actually read. No wrappers, no subscribe, just logic. And look at the start at the bottom. 57% performance improvement. We aren't just talking about a raw throughput, we're talking about development velocity. That is the speed at which you ship features and fix bugs. If you are still wrestling with reactor chains, this video is your exit strategy. Stick around because we are breaking down the biggest paradigm shift in the Java history. So let's define the problem. Why do developers struggle with Webflux? It's not because we aren't smart, it's because of cognitive load. Look at this code snippet. We call it callback hell reinvented. You start with repo.find by ID, then you flat map, then you filter, and then you zip with pricing. And suddenly you are 5 level deep in a lambda function. You lose the flow of business logic entirely. And God forbid, you have an error. Look at the stack trace icon. When an exception is thrown here, the stack trace doesn't tell you where your logic failed. It points to some internal reactor.core.publisher class inside the library. Debugging this at 3 a.m. isn't engineering, it's archaeology. You are guessing where the error happened. This leads to the bottom box, the productivity hit. Writing the code takes longer. Reading it takes even longer. And hiring for it? Good luck finding a junior dev who understands switch if empty on day one. But we have to respect the architecture. Webflux isn't garbage. It's a Formula One car. It runs on Netty. It uses a non-blocking input-output event loop architecture. Think of it like this. You have a small number of threads, usually matched exactly to your CPU cores. They handle incoming requests, those doors at the top. They take the request, offload the work, and immediately go back to the next one. They never block. This is why Webflux is incredible for streaming, API gateways, and high concurrency scenarios. It maximizes hardware usage like nothing else because the CPU never sits idle. But there is a catch. To make this work, you, the developer, cannot block the thread. Ever. One thread dot sleep and the whole system chokes. So here is the trade-off calculation you need to make. On the left, excellent throughput. You can handle massive concurrency with minimal resources. Mature ecosystem. It's been around since Spring 5. It integrates with security and cloud gateway perfectly. And back pressure. That is the killer feature. The ability to tell a producer to slow down so you don't crash your consumer. That is superpower for data streaming. But look on the right, the steep learning curve. It requires a fundamental shift in thinking. Hard to debug. Operator hell is real here. And the big one requires reactive drivers. You can't just use standard JDBC. You need to migrate to R2DBC. If you have a library that blocks, you can't use it. If your database driver is old, you can't use it. The viral complexity means your entire stack must be reactive, or none of it is. So now enter the challenger, which is Java 21 Virtual Threads, Project Loom. This changes the rule of physics for the JVM. Instead of one Java thread mapping to one heavy operating system thread, which limits you to a few thousand threads because they cost 2 MB each, virtual threads are managed by JVM. They are lightweight objects that live on the heap. They cost bytes. You can create millions of them. Here is the magic. Blocking is free. Whenever your code hits a database call or any input output operation, the JVM will detect it. It unmounts the virtual thread, parks it, and frees up the real carrier thread to do other work. To you, it looks like blocking. To the operating system, it looks not. And the configuration, it's really simple. You just need to add spring.threads.virtual.enabled equal to true in your Spring application. One line of config in Spring Boot 3.2 plus, and suddenly you get a reactive scalability with imperative code. Let's look at the ROI. Writing blocking, you can use for loops, you can use try catch blocks, no more callback hell. It's easy debugging now. Your stack traces look normal. You can step through debug in IntelliJ just like you did in 2015. JDBC compatibility. This is huge. It works with existing blocking JDBC drivers. You don't need to rewrite your database layer to use R2DBC. But pay attention to the warning on the right. That's thread pinning. If you use the synchronized keyword inside a blocking operation, the virtual thread gets pinned to the carried thread. It cannot unmount it. While modern libraries have replaced synchronized with rent lock, if you are using legacy code or old XML parsers, this can hurt your performance. Also remember, Java 21 Plus is required for using virtual threads. If you are stuck on Java 8 or 17, this conversation is over. You must upgrade your runtime first. Let's put them head to head. Where do we stand in 2026? Coding style. Virtual threads win here. Imperative is just simpler than functional declarative chains. How about debugging? Virtual threads wins here too. Standard stack traces versus disconnected ones. The library compatibility. Virtual thread wins again here. It works with any blocking library. And the DB drivers, virtual threads is again the winner. Use standard JPAs, Hibernate JDBC. No changes needed. But look at the bottom row, streaming. Webflux is still the king there. It has a native first class support for flow control. Virtual threads can do it, but Webflux was born for it. And regarding max throughput, it's a draw. They are both extremely high, which leads us to the numbers. I want you to look closely at this chart. This is a real production data on AWS C5 large instances. Throughput. Throughput. Webflux hits 653 requests per second. Virtual threads hit 614 requests per second. So yes, Webflux is technically near about 6% faster in raw request processing because it avoids context switching entirely. But look at the memory usage on the right. Virtual threads use 40% less memory because they reduce heap pressure compared to the reactive wrapper objects. And look at the bottom right, 57% improvement in development velocity. Ask yourself, is gaining 6% in raw throughput worth sacrificing 57% of your team's speed? For 99% of companies, the answer is no. Virtual threads are fast enough to handle massive scale, but they are simple enough to keep your team sane. So here is your decision framework for 2026. Screenshot this. Ask yourself, what is the primary workload? Is it the high concurrency streaming, video, infinite data feeds, or massive real time chat apps? Stick with Webflux. It handles back pressure better than anything else, and the complexity is worth it for that specific use case. Is it standard REST APIs or a typical microservice? Are you using traditional JDBC's JPA? Go for virtual threads. There is no reason to torture yourself with reactive chains for a simple get users request. Virtual threads are the default for general purpose backend development. So when you are in a system design interview and they ask, how do we handle concurrency? Here is your four-step power answer. Start with the virtual threads. For any new blocking input output service, I default to virtual threads because of the simplicity performance ratio. Then mention streaming. However, I would still choose Webflux for a high throughput streaming or extensive back pressure needs. Discuss the trade-offs. The trade-off is engineering cost versus raw throughput. Virtual thread gives us better developer experience. The future outlook. The ecosystem is converging on Loom. It's the future standard for the JVM. And note the pro tip. If the team already has 50 Webflux services, don't suggest a rewrite. That would be a red flag. Context is the king here. Let's wrap up with this key takeaways. Virtual threads is equal to performance plus simplicity. You no longer have to choose between high throughput and readable code. Keep Webflux for streaming. Don't rewrite working reactive pipelines. It is still the king of back pressure. The 2026 strategy. Default to virtual threads for new REST APIs and microservices. Look at the code snippet. Executors.new virtual thread per task executor. It looks like blocking code. It looks simple, but underneath it scales like a cloud native beast. That is the beauty of Java 21. Now I want to hear from you. Are you team reactive? Do you need that raw throughput and streaming power? Or are you team Loom? Do you believe simplicity is the ultimate sophistication? Vote in the comments right now. I want to see which stack wins the debate. If this deep dive helped you understand the future of Java, hit that subscribe button. We are dropping more system design breakdowns every week. Thanks for watching.